For decades, vitamin D has been typecast as the bone vitamin, praised primarily for its role in calcium absorption and the prevention of rickets and osteoporosis. While these functions are critical, they barely scratch the surface of what vitamin D actually does in the body. Recent scientific advances have dramatically expanded our understanding of vitamin D's influence, placing it not merely as a nutrient, but as a powerful genetic regulator with implications that reach into nearly every organ system. At the heart of this wider role lies one of the most important revelations of modern health science. Vitamin D plays a key role in genomic stability, cellular defense, and even the modulation of biological aging. Unlike many other vitamins that act passively as cofactors, vitamin D behaves more like a hormone. Once converted into its active form, calcitriol 1,25-dihydroxyvitamin D, it binds to the vitamin D receptor, VDR, found in the nuclei of cells throughout the body. This VDR then partners with other molecules to bind to DNA itself, influencing the expression of hundreds of genes. In fact, it's estimated that vitamin D directly or indirectly regulates over 3% of the human genome. This means vitamin D doesn't just support one system, it helps to orchestrate cellular behavior on a broad scale, affecting immune function, inflammation, cell growth, apoptosis, and DNA repair. One of the most groundbreaking areas of research involves vitamin D's role in protecting genomic integrity. Our DNA is constantly under assault from various stressors: UV radiation, pollution, poor diet, inflammation, oxidative stress, and even the byproducts of our own metabolism. Over time, these insults can lead to mutations, chromosomal damage, and the breakdown of normal cell function. Left unchecked, this can result in accelerated aging, cancer, and degenerative disease. Vitamin D contributes to genomic stability in several important ways. First, it enhances DNA repair mechanisms. Studies have shown that cells exposed to adequate vitamin D have an improved ability to identify and repair damaged DNA strands, thanks in part to the upregulation of genes involved in nucleotide excision repair pathways. This helps prevent mutations from accumulating and reduces the risk of cellular malfunction. Second, vitamin D helps to regulate telomere length, a vital marker of biological aging. Telomeres are the protective caps on the ends of chromosomes that shorten with every cell division. When telomeres become critically short, cells enter a state of senescence or programmed death, an essential safeguard against cancer, but also a driver of tissue aging and chronic disease. Low vitamin D levels have been correlated with shorter telomeres, while supplementation has shown promising results in slowing telomere erosion, especially in individuals under oxidative or inflammatory stress. Third, vitamin D has a profound effect on oxidative stress and inflammation, two primary forces that contribute to DNA damage and cellular aging. By modulating immune responses and reducing the production of pro-inflammatory cytokines like IL-6 and TNF-alpha, vitamin D creates a more favorable cellular environment, one in which DNA is less likely to be harmed and cells can maintain their normal repair functions. In essence, vitamin D acts as a kind of molecular peacekeeper, protecting the genome from environmental insults while reducing the inflammatory background noise that accelerates biological wear and tear. Beyond the nucleus, vitamin D's genomic effects ripple outward to influence organ systems. In the brain, it helps regulate neurotransmitter synthesis and protects against neuroinflammation, offering a potential buffer against age-related cognitive decline. In the immune system, vitamin D modulates both innate and adaptive immunity, boosting antimicrobial responses while suppressing autoimmune overreactions. In the cardiovascular system, it contributes to endothelial function, blood pressure regulation, and protection against arterial calcification. This expanding field of research has shifted vitamin D from being viewed solely as a bone health supplement to a system-wide regulatory agent with relevance across disciplines, from oncology and neurology to immunology and gerontology. Randomized controlled trials and large cohort studies have linked adequate vitamin D levels not only to stronger bones, but also to lower risks of cancer, diabetes, cardiovascular disease, autoimmune disorders, and all-cause mortality. Importantly, vitamin D deficiency is widespread, especially in modern indoor lifestyles and in higher latitudes where sun exposure is limited. As people spend more time indoors, use sunscreen, and wear more protective clothing, their ability to synthesize vitamin D from sunlight diminishes. Diet alone is often not enough, since few foods contain meaningful amounts of vitamin D. This widespread deficiency is not a minor problem. It is a silent epidemic that may be undermining genomic resilience on a population level. Supplementing with vitamin D, especially in the form of vitamin D3, cholecalciferol, is a simple and affordable intervention with far-reaching benefits. While the optimal dose can vary depending on age, weight, health status, and geography, many experts now recommend a daily intake of 1,000 to 2,000 IU for most adults to maintain blood levels in the range of 40 to 60 nanograms per milliliter, a range associated with the best outcomes for cellular health, immune balance, and telomere preservation. In conclusion, the traditional narrative of vitamin D as a bone health vitamin is woefully outdated. Today's science reveals vitamin D to be a central player in genomic protection, cellular communication, and the defense against biological aging. By supporting DNA repair, preserving telomere length, reducing inflammation, and enhancing immune function, vitamin D offers a broad, system-wide strategy for maintaining health deep within our cells. Far from being just a supplement for the elderly or at-risk populations, it is rapidly becoming one of the most important tools in our collective effort to age more slowly, stay biologically resilient, and preserve quality of life well into the later decades.